Okay, a radar unit is used to measure the speed of cars on a motorway. The speeds are normally distributed. It is observed that 6.7% of the cars travel less than 75 kilometres per hour, while there is a 15.87% chance that the cars will travel greater than 100 kilometres per hour. Determine the mean and standard deviation of the cars to the nearest whole number. Okay, so first thing we're going to do is the probability that these things occur is equal to that. So first thing I'm going to do is I'm going to calculate a z-score for each of them. Okay, so let's go menu, statistics. Now we're going to go distribution, normal, inverse normal. The distribution is going to go. Now for this one, if I draw a picture of it, there's x. X is less than 75, so we're going left. The area is 0.067. If you miss this 0 here, that turns it into 67, so don't do that. Standard deviation is going to be set to 1 and 0 is the mean. So that's going to give me just a z-score, and then later on I can convert that into having an actual mean and standard deviation. So that one is going to give me negative 1.4985. Okay, and for the other one, exit, these are going the opposite way, so this time I'm going right. Ooh. Oh, I don't know what's happening. Stop that. Oh, okay. Distribution, normal, inverse normal. Right. That one's going to be 0.1587. Okay, and that's going to give me 0.9998. Okay, so now I've got my two z-scores. I've got enough that I can solve simultaneously. The only thing we need to remember is to calculate an actual score. The z-score is equal to the score minus the mean over the standard deviation. So I've got this information, which is your z-score. So I've got this here, and I've got this one over here. So the only thing I'm really still trying to find are these two. Now, because I've got that in two different equations, I know I'm solving simultaneously. So I'm going to straight away rearrange this. So it's going to be standard deviation is equal to z, score minus the mean over z. And I'm going to do this for both pieces of information. Okay, so score for the first one is 75 minus the mean over negative 1.4985. That's going to give me my deviation. This one over here, the deviation is going to be equal to, 100 minus the mean over 0.9998. Now I'm going to go to my regular calculator, the run matrix, and I'm just going to solve these using solve n because I can. So first one, 75 minus our mean all over negative 1.4985 is equal to fraction 100 minus the mean all over 0.9998, comma, x, close the bracket, execute. Okay, so that gives me an answer that our mean, now it's not the standard deviation because I've made these two equal to each other, meaning that the variable that we've solved for is the mean. So the mean here is equal to 89.99 or 90 kilometres per hour. Okay, so now to find the standard deviation, I'm going to substitute this back into here. So 75 minus 90 over negative 1.4985. And that's going to give me 10 point something. So the standard deviation is equal to 10.